or analysis of a structure, well, because wind loads are actually causing imbalance, or when you subject the specific structure into wind, it tends to move. Okay, so similar to your live loads, it causes vibration. Okay, and when something vibrates, the more unstable it is. So that's why in the analysis of your building frames, we have wind loads. Okay, have you encountered wind loads in doing models sa steel ninyo? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, okay. Okay, mabilis lang ba yung provisions na binigay ni ganon, ni Sir June? Ay, magaling yun magturo si Sir June eh. Naintindihan niyo ba yung mga pinagbibigay niya? How did you compute the wind load, mga ganyan? No? Okay lang yan, guys. Okay lang yan. Okay, so wala namang problema dyan. Okay? So I'll be giving you a lot of tutorial videos later on pag nag-midterm na tayo. Okay? So how do we actually tackle wind loads? Okay, so in our topic, we will be dealing with the procedures. Okay, general lang to. Although sobrang dami guys ng provision sa ASCA and NSCP ng wind loads, sobrang dami niya, hindi natin kayang tapusin yun ng one sem. So I will just be introducing to you the general requirements. Okay, kung ano ba yung mga ginagamit na variables, mga ganyan, mga gas factor, mga ganyan, yung mga ini-input natin sa ISTAAD. Okay, anyway, hindi naman tayo guys nagko-compute mismo sa ISTAAD. Okay, we just input the values. Okay, the values only. Pero hindi na tayo mismo yung nagko-compute ng required na ganun, na variables. Okay, we just input kung ano yung binibigay code. Okay, so scope lang ng ating wind load will be for main wind force resisting system, or the MWFRS, as well as components and cladding. Okay, so it's up to you. I'll just leave to you, okay, what components and cladding means. Okay, we're just gonna focus on more of the topic. We'll just focus on the MWFRS. Okay, so that will be discussed chapters 26 through 31. So ganun kadami guys. 5 chapters ng ESCE wind loads. Okay, so what are the permitted procedures? Okay, so the design of the wind loads for buildings and other structures, including the MWFRS and CNC, okay, those are the abbreviations, guys, shall be determined using the procedures specified in this section. So that will be the general requirements will be discussed chapter 26, but the specifics, okay, of the design will be discussed chapter 27 hanggang 31. Okay, so next slide tayo. So how do we, what are the procedures in determining the wind loads, okay, for MWFRS? So we have actually 4 types of procedure in determining it. So the first one is directional procedure. Next, second one is the envelope procedure, and then directional procedure for building appurtenances, and wind tunnel procedure naman for all buildings other than if it does not fall among the 3 the first 3 that I mentioned. So yung directional proceedings na yung directional procedure, the first one is actually dependent of the height. Actually lahat naman sila dependent of the height. Okay, so yung directional procedure will be thoroughly discussed in chapter 27. Okay, for buildings meeting the requirements specified therein. And then we have the envelope procedure. This is for low-rise lang. Okay, low-rise buildings. And we have directional procedure for building appurtenances or rooftop structures and rooftop equipment and other structures. Okay, so yung first procedure actually deals with high-rise buildings. Okay, the second one, low-rise. The third one is those located on the roof decks. Okay, iba ang analysis nun kasi it's not part of the MWFRS as a whole. Okay. Okay. And then other than that, if hindi naman pasok yung inyong structure doon sa tatlo, okay? we will be doing the wind tunnel procedure. Okay? So, next po tayo. For components and cladding naman, for components and cladding, next slide tayo please. Okay. So for components and cladding, we have two general procedures that we need to do. Okay, we have the analytical procedure and wind tunnel procedure naman. But we will not be focusing on the components and cladding. Okay, we will just be focusing on the MWFRS. Okay, so yan yung the first one is analytical procedure, which will be tackled sa chapter 30. Pero hindi na tayo aabot doon kasi we're just focusing on the general requirements. Okay, sobrang dami kasi yun. And then second one is the wind tunnel procedure. Okay. So next slide will be the definitions. Okay, so I'll just leave that to you kasi sobrang dami ng definitions dito, guys. Okay, it is important for you to know the definitions. Okay, because upon reaching the general requirements in each section, baka ma-confuse kayo kung ano yung ibig niyang sabihin. Okay, yung ibig niyang sabihin. So it is required for you to read and understand what these definitions are. For example, do you know that the definition of a low-rise building depends on the mean roof height? And yeah, it depends on the mean roof height. So for building at low-rise, dapat yung mean roof height niya is less than or equal to 18 meters. Okay, so the average height of the roof should be 18 meters. That is your low-rise building. Okay, and another one is that yung mean roof height mo does not exceed least horizontal dimension. So dapat hindi siya bumaba sa minimum stated by the code, the standard. Okay? So, yun yung mga definitions natin. So, meron din tayong mga open building, mga ganyan, and then partially closed na building, and closed, mga ganyan. It's up to you na to read that one. Okay? Pero nandun na lang yung definition. What do we mean when we say open building? Mga ganun. So, a certain percentage of the building is actually open. It depends on the number or the area of the windows. Mga ganyan, guys. So, yun yung ating mga definitions. Okay? So, meron tayo dyan, basic wind speed. Ano ba tong basic wind speed na to? Mga ganyan. And then building and closed building. Ganyan. So, it's up to you to read that one later on. Okay? I will just be talking about the sections na lang. Okay? So, next chapter po tayo. Hanapin natin yung graph or yung figure. Sige pa. Ayan, dyan tayo magstay. Doon sa may figure kanina. Balik tayo doon sa may figure. Ayan. So, this will be the flow of the wind load. Okay? The wind load in general. Okay? So, chapter 26 of the ASCE will talks about the standard values. Okay? Standard values and variables. Now, for the analysis, okay, yung next dyan, chapter 27, 28, 29, and 31, those are actually talking about the procedure on how you're going to apply the wind load. Okay? Pero hindi na natin yan gagawin. Okay? Kasi si STAAD na or yung frame na natin or yung software na natin ang gagawa niyan. So, yung first column dyan, on your left side, okay, on your left side, na nakikita nyo, I don't know if that's your left or right. On the left side, that's the procedures for the MWFRS. We have 4. And then chapter 30 and 31 naman will be the procedure for components and cladding. Okay, the CNC. Okay, so yan yung outline ng process natin for determining the wind loads. Okay, proceed tayo sa 26.4. Dear sa 26.4 tayo, general. Hanapin mo lang yung general. Sige, baba ka pa. Okay, lagpasan na natin yung mga yun. Kasi those are, ayun. Balik ka. Ayan. So, ito yung general natin. General request. Okay, so for the sign convention, if the pressure of the wind is actually acting towards the object, it is positive. Okay, if it acts away from the object, it is negative. Okay, so that's the sign convention. And then critical load condition natin, values of external and internal pressure shall be combined algebraically. So you just need to get the summation of the components or the summation of the pressure. Apply lang statics dyan, guys, okay, to get the critical load condition. If both of them acts towards, or if both of them acts in the same direction, di ba, you add them. Pero if they are opposing forces, you subtract them. So that's what we call, or that's the process of algebra, okay? Algebraically determination, okay? Next, we have wind pressures acting on, sige. Sabagay, pareho lang din naman yun, guys, okay? So, doon sa 26.4.3, yan, wind pressures acting on opposite phases, yun lang din yun, okay? You just need to get the algebraic sum, okay? So, proceed tayo doon sa wind hazard map. So, ano ba itong wind hazard map na ito? Actually, we have that, okay? We have that as well. So, dito sa wind hazard map, it actually just tells you, it is actually a map. It is a map, literally. It just tells you the average wind speed at that particular area, okay? Using parang contour lines. Parang contour lines siya, guys, okay? Later on, meron tayong sample niyan. Okay, so next slide yun. I think next slides will have the example. Pero dito sa basic wind speed, how do we determine this one? Okay, so for basic wind speed, guys, okay, that's the V. Tandaan, basic wind speed is the V. We use this in the determination of the wind load, okay, and other structures, we can identify these using figures 26.5-1-2, okay? And then to identify as well the risk category, okay? The risk category of the building, okay? So if your structure is under risk category 1, okay, you use figure 26.5-1A and -2A. Now, similarly, if it is under category 2, okay, you use 26.5-1B and 26.5-2B, and so on and so forth. So the values of your basic wind speed depends on the risk category of the area, okay? And the wind shall be assumed to come from any horizontal direction. Okay, so the basic wind speed shall be increased where records of or experience indicate that the wind speeds are higher than those reflected in the figures that will be given later on. Ngayon, yung basic wind speed natin, guys, hindi siya nagbabago. Hindi siya stationary. Okay, kumbaga yung values niyan, hindi na yun yung final value because effect of climate change. Yung mga basic wind speed natin tumataas or bumababa, but normally it tends to go up. Okay, tends to go up. Especially, a common scenario about this one is when, wait lang, tumatawag si Sir. Hello, sir. Good morning. Good afternoon po.
Hello, Julius.
Yes po.
May klase ka?
Ay, meron po, sir, 1:30 to 4:30.
Anong oras na ba?
2:11 po, sir. Bakit po, sir?
Yeah, ilang units ka na?
20, I think that's 27. Wait lang, sir. Check ko. Bakit, sir? Bibigyan mo ako ng load?
Pwede mong hawakan ng isang foundation and retaining wall design. 60 kung sakali.
60 students?
60.
Ay, substitute na naman, sir. Sir, ayoko na mag-substitute.
Bakit?
Hindi kami nababayaran ng tama. Joke lang. Ayun. Bali, sir, I'm units ko ay isa lang yung bigay niyo sa akin.
Oh, gusto mo dalawa?
Oh, wait lang. Let me think about it. Hindi. Ilang units na ba ako? Wait lang, sir. 24 units naman, sir, yung nakalagay dito. Fourth year din, sir. Ito lang din mga to. Wait lang, sir, ha. Tanongin ko sila. Hello, guys. Balik kayo foundation design.
Meron, sir.
Meron, sir.
Well, may teacher po
Meron,
yun? Ay, meron na. Sir, anong code po yan?
Wala pa kaming prof.
Wala pang teacher, sir.
Ay, wala pa kayong teacher.
Wala pa.
Wala pa po.
Ay, okay.
Sir.
Wala pa daw silang teacher.
Ang gusto mo kamakan yung dalawa kung sakali.
Gusto niyo ba?
Yes, sir.
Balik
Yes, sir.
10 units.
Sir, yung
Yung
code,
set one,
yung code na lang namin.
Then you need to 34 me.
Sir, yung code na lang namin kunin mo.
Yung set 1, sir.
Sir, yes,
Set
sir.
1, sir, set 1.
Set 1, sir.
Okay. Dalawa, sir. Dalawa, no?
Kaya mo.
Basta i-move nila ng gano'n ng Monday, Tuesday yung pasok.
Bahala ka na kung sakali.
Sige, go na. Para sa bayan. Para sa bayan, sir, go. Pero,
Bale, 24 ka ngayon,
yes, plus,
plus substi. Ewan ko kung paano gawin nito. Substi natin. Hindi, kasi, sana ma-hire si Juan. Hello?
sino, sir?
Si Kabawatan. Siyang prospect ko.
Ayun nga, sir. Kasi, wala naman akong problema dun sa RC and dun sa Bintahing Load, CAP. I very much like them. Pero foundation,
Wala din.
hindi ko sure kung ganon, kung makakan ko ba siya, ma-handle ko siya tama. Pero I'll try my best. I don't want to disappoint you.
So, ikaw at si... Hindi naman nagre-reply si Renz.
Ayaw
Pero
niya,
contact ko.
ayaw niya, sir.
Ay, ayaw na niya.
Oo, baka ayaw na niya. Ayun. Ilang units yun, sir, yung idadagdag?
Bale, 3 yun eh. 3 hours left, 3 hours lang.
Again?
5 units sa'yo.
Pero feeling ko kasi, sir, ganun, if to take that, magko-conflict na siya naman siya. So, i-move ko siya ng Monday and Tuesday. Mag-move ko siya.
Kung na lang, i-arrange, anyway, estudyante mo naman sila, di ba?
Yes.
Conflict na yung, wag lang yung teleconferencing.
Okay. So, pwede kong gamitin yung lab namin for the foundation, ganon. Para hindi ko na ganon. Pwede lang yun, sir. Okay. Sige. Yung lab namin sa RC gamitin ko for ganun. Para hindi na ako mag-ganon. Kasi ang hirap, sir, ng mga ganyan.
Oo nga, substitute naman ito, papas na si Tim.
Baka naman kasi, sir, yung substi naman na niya yan, abot na naman ng 1 sem.
Okay na, di may maipon na, ano? Hindi, sana ma-hire na within this week or next week.
Hopefully. Hopefully, sir. Sige. Sige, sir. Kuha ako ng dalawang class. Kung gusto mo, ilan ba sir ng ganun, ng foundation ngayon?
3 yun, ibigay ko kay Santos yung isa, nag-okay naman yan.
Binigay mo lang sana sa akin lahat, sir. Joke lang.
Teka, wala na, bugbog ka na sa type ko.
Okay naman, sir. Single naman ako. Wala naman akong ganun. Wala naman akong... Joke lang. Sige, sir. Dalawa. Sige, kunin ko na yung dalawa. Substin.
Sige.
Okay, sir. Sige po. Thank you po. Bye-bye.
Okay.
Sir, code 889.
889, sir, code.
Code 889, sir.
Ako na mag-share screen, sir.
889 na naman. Ayoko ng ganun. Ito na naman tayo. Hindi kasi nakuha na ako dun sa substi na yan. Kasi last semester, substi ako for like how many years? How many years tuloy? How many months? Tapos hindi kami binabayaran ng tama. Actually, hindi ko pa nga nakukuha yung bayad ng substi. So parang ang hirap mag-substi binabayaran. Yun lang naman yung sakit ng loob ko na substi ka. Alam mo guys, pag substi ka kasi, hindi siya kasama, wala kang benefit for the substi. They just pay you per unit, pero hindi siya kasama sa third pay. Hindi siya kasama sa mga benefits mo. Yun yung kwan doon. Yun yung parang flaw. Okay, and then ang subsidy kasi good pag lumagpas na ng 1 month na subsidy ka, dapat permanent ka na doon. So dapat magkakaroon ka na ng sige, magkano din yun, no? So sabihin natin 6 units. So that's additional 6,000 for me. Okay? So hindi ka nila babayaran ng 6,000 sa 13-month pay. Mga ganun. Kaya sa bonus mo hindi siya kasama. Ganun. So ang ibabayad lang sa'yo is yung regular na units. Pero yung subsidy mo gano'n. So parang nagdadalawang isip ako kasi I really like my schedule na. Pero ayun nga, na marami din ako pinagkakagastusan. So go na. Ayan, go na. And then nung nalaman ko kayo lang din palang foundation. Ha? Let's just talk about that. Anong code to? Sige, 889. Hindi ko lang sure kung anong gusto ni Sir na ibigay sa akin na code. Pero si Santos naman yung isa, okay lang naman yun. Kasi mabait naman si Santos. Okay? Actually, hindi nga naman masyadong papasok. Hindi nga masyadong pumapasok si Santos. Okay? Pero ang deal natin, guys, is that I'll just make the foundation and retaining wall design. Kumbaga, more on theoretical. Okay? More on code basis lang. Okay? Code basis lang yun. We won't be doing very much competent dyan. Okay? More on code basis. Okay? Mas gusto ko yung mga code basis kasi hindi naman talaga tayo nag-design ng pure computation. Rather, we use softwares on one. Okay. Okay, so let's just see, guys, kung mabigay sa inyo yung mabigay yung klase ninyo sa akin. Okay, let's hopefully. Okay, hopefully. And then don't worry, yung requirements niyo doon will be just the same as the requirements we have here. Okay. So ayun lang. Okay. So yun lang yung mga ganun. Gusto niyo ba ako? Like, why do you want me anyway? Sige, flatter me. Why do you want me as your instructor? Feeling ko naman wala kang natututunan sa akin. Diba? Quiet kayo. Okay. So, ganyan. Plastikan. Ganun. Joke lang. Sige. Okay. Let's just wait for the announcement later on. So, kailangan ko i-take note yun, baka hindi na naman ako bayaran. Okay. So, these are the risk categories. Ayan. Boss kasi hindi pwedeng tumanggi. Alam niyo naman. Ayun na ayaw kong tumatanggi. Okay. Kay Sir Vega. Okay. So, ayun. Okay, let's proceed. Earlier, I mentioned that the values of the wind speed, okay, the V, is actually taken from the code or given by the code. But in the instance, because of the climate changes and the changes in the environmental phenomena, hindi standard yung basic wind speed. It can go higher, it can go lower. So what are we going to do? We need to consult the experts, okay? The regional climatic data, for example, Pag-asa, ganyan, to check on the basic wind speeds of that particular place. Okay? So, for example, yung Yolanda natin, 4 hanggang signal number 4 lang tayo. Pero because of what happened with hurricanes and parang above normal na, or above the standard natin, like 250 kilometers per hour. More than that pa yung wind speed. I'm not just sure, pero because of that, nagkaroon tayo ng changes on the code. So, tinaasan nila yung values ng ating wind speeds, ganyan, including the gust factors. Okay? So, meron din tayong mountainous terrain, guys. So the basic wind speed for the mountainous terrains, gorges, and special wind regions shown in figure 26.5-1 shall be examined for unusual wind conditions. Okay? So if your place, even though meron kayong a value for the wind speed, it doesn't mean that that is your wind speed at that particular area, especially if you are in mountainous terrain. Because ang assumption in natin is horizontal. Okay? Horizontal siya. Pero in the cases of mountains and terrains, since hindi naman siya flat, okay? Ang wind speed natin is nagva-vary. Okay? So there will be some adjustments, pero it's not the engineer that does the adjustments. It's the expert in the field of meteorology. Okay? So yun yung special wind regions. Next, meron din tayo estimation of basic wind speeds from regional climatic data. Ito na yung pumapasok, guys. Dito na yung sinasabi ko before na ano to, sinasabi ko before na the wind speeds actually depends on your design, okay, and the updates, okay. So meron tayong modifications or estimation of the basic wind speeds, okay, and these are necessary first when approved extreme value statistical analysis procedures have been used in the reducing the data, okay. So hindi tayo yung gumagawa ng estimation of basic wind speeds. Okay, that's the bottom line here. Hindi tayo yung gumawa nun. Okay, unless you are a wind engineer specializing in wind engineering. Okay, another is the estimation is acceptable if the length of record or sampling error average time. Okay, anemometer height, data quality, and terrain exposure of anemometer have been taken into account. Of course, we will do experiments, okay, on the field, okay, especially if you are in a mountain. Hindi mo kayang pwedeng isang anemometer lang yung gamitin, mga ganyan. So there will be sampling points, a lot of sampling points. The more sample points you have, the more accurate the data is, okay? So yun yung dalawang condition in estimation of basic wind speed. Okay. So next tayo, this is now the climatic, this is now the wind map. Okay. So as you can see, meron tayong mga like curves dyan. So those curves actually tells you the average wind speed at that area. Okay, so I think this is Alaska, and then this is the east coast of USA. So since we're using the ASCE standard, baka hindi tayo makarelate dyan. Okay, hindi tayo makarelate. Okay, pero meron din tayong wind map, guys, sa NSCP. Okay, we don't have kasi, ang problema kasi sa atin, sa school, wala silang NSCP na e-file. And nabibili kasi yun, that's like worth 2,000 pesos, and they can't even provide us with the NSCP, yung authentic na copy. That's why ASCE yung ginagamit natin. Okay? So anyway, the curves there indicates uniform wind speed along that path. Okay? So kung nag-fall man yung inyong place at that curve, so that is your wind speed. What if nag-fall naman yung inyong location between two separate contour lines? Sabihin na lang natin contour lines yan. Okay, it's similar to your topographic map. So if nag-fall siya under between two contours, do we get the average? Do we get the average of the two? And that's your wind speed na? Yes or no? Yung highest. Yes. We need to choose between the two, whoever is the highest. Okay? We don't do averaging, rather we choose the highest one. Okay? If it is between those two contour lines. Okay? So, meron mga notes dyan on the next slide. Ayan. Meron na next slide will be the notes, okay, about the wind map. Ayan. So, next tayo, dear Prince. Ayan, those are the notes. So, basahin nyo na lang yan later on. Next slide. Okay. This is the continuation of the wind map. Okay, as you can see, pwede din palang yung wind contour is actually connected to the other end. So that's similar here, the 105. So yung 105 dyan, yung mga 195 na yan, guys, yung mga ganyan, those are in terms of miles per hour. Okay, for I think that's miles per hour. Basta. And then yung naka-parenthesis, that is in SI units. So that's 48 kilometers per hour, mga ganyan siguro, or like 48 meters per second, mga ganyan. Okay? So, ayun. And then naman, guys, dun sa may location, ganyan, as V, MPH, and then MS, mga ganyan. So, next tayo, we have the wind directionality factor. So, the wind directionality factor takes into consideration the direction of the wind. Okay? So, the direction of the wind. Is it from the east side, the west side, the northern side, or the southern side, or is it on the facade of the building? Is it at the rear portion of the building? Mga ganyan. Okay? So we need to take into consideration the wind direction. Okay? So these are the wind directionality factors. We have KD, and then we have the building or the structure type. So since we are going to, wala naman siguro magde-design dito ng naka-arc na roof, naka-circular dome, no? So mag-stick na lang tayo sa box type. Okay, sa box type na building. So what we're going to need is, or what we're going to use as the directionality factor is the 0.85 because we are doing MWFRS na analysis. Okay, we won't be doing components and cladding. Okay, so 0.85 tayo. Ngayon, yung directionality factor ninyo can be 0.95. Those are only for round or octagonal structures with non-axis symmetric structural systems. Okay? Pag sinabi natin non-axis symmetric, hindi siya pareho on both sides. If you're going to cut the structure into two, pareho ba sila ng structural system? Pareho ba sila ng shape? Mga ganyan. Okay? Pareho ba sila ng structural characteristics whatsoever? Okay? So, proceed next slide. Okay. So, we have naman yung wind directionality. Okay. So, the wind directionality factor, KD, shall be determined from table 26.6-1. Okay. So, meron tayong, I think that's the table earlier. Okay. And shall be included in the wind loads calculated in chapters 27 to 30. And the effect of wind directionality in determining wind loads in accordance with chapter 31 shall be based on excuse me, ayan, so in accordance with chapter 31, pero hindi na tayo aabot dun sa chapter 31. Okay, next tayo, exposure. Okay, so we have exposure as well. What do we mean when we say exposure? Siyempre, we cannot just consider the direction of the wind, but rather we need to consider as well how close the building is. So mayroon kasing affect yung structures niyo around the building. Okay, so na-obstruct niyo yung wind path. So that's why we have exposure sections in here. So for each wind direction considered, the upwind exposure shall be based on ground surface roughness that is determined from natural topography, vegetation, and constructed facilities. So that is your exposure. Now your wind directions and sectors for each selected wind direction at which the wind loads are to be determined. Okay, so it is up to you guys. And the analysis kasi later on, sa harap, sa likod, and then sa kabilaang side, yun yung i-consider natin na direction ng wind natin. Now, okay, now we need to consider upwind sectors extending 45 degrees on either side of the selected direction. Siyempre, in the case of horizontal, the assumption is horizontal. Okay, the assumption is horizontal, but we need also to consider at least 45 degrees from the horizontal wind directions. Okay, so normally kasi yung wind, ang assumption niya is isang buga lang ng ganun din straight line, pero it's not, because when you actually blow, okay, a gust of wind, it's the different direction. So that's why instead of having like horizontal, we also do like 45 degrees, okay, from the horizontal, upward and downward. Okay, so yun yung basic scheme ng ating analysis for the wind directions. Okay, so meron tayong exposure types later on, meron tayong exposure types. Okay, but right now we're going to consider surface roughness categories. Okay, so ano ba tong surface roughness categories na to? Okay, so from the word itself, it's surface roughness. Okay, what, kumbaga textural, okay, parang textural. Okay, so in terms of in a massive scale textural siya because we're considering yung obstructions. So we have different types of surface roughness here. We have surface roughness B, C, and D. Wala tayong surface roughness A. Okay, so for surface roughness B, identify nyo lang guys, lahat ng surface or lahat ng place na urban, suburban areas, wooded areas, or other terrain with numerous closely spaced obstructions. Okay? Yun ay surface roughness B. Okay? For surface roughness C naman, ito naman yung mga open terrains. Okay? Pero yung, meron din siyang obstructions, meron din siyang obstructions, guys. Pero yung obstructions yun is generally, okay, in average, less than 9.1 meters. Okay, that's surface roughness C. Now, for the surface roughness D naman, ito yung mga flat and unobstructed. Okay, so normally in our profession, ang ginagamit natin is surface roughness D. Okay, kasi it's more conservative in terms of the design. Now, surface roughness D, saan ba makikita ito? Well, guys, fun fact, ito guys, normally yung mga coastal construction. Okay, coastal constructions natin. Especially if your structure is located in the middle of the sea. For example, yung oil drilling na, yung mga oil extraction facilities natin in the middle of the sea, ang surface roughness category nun is D. Kasi very open siya to air or to wind loads. Okay? So yun yung example ng ating surface roughness D. Next, we have 26.7.3. Next slide po. These are the exposure categories. Actually, yung exposure C dyan, guys, or yung exposure B dun sa baba, kadugtong niya yan nung under sa exposure C. So, i-edit ko na lang yan later on and i-upload ko na lang. Okay? So, for exposure B, for buildings or other structures with a mean roof height less than or equal to 30 feet, exposure B shall apply where the ground surface roughness as defined by surface roughness B prevails in the upwind direction or a distance greater than 1,500 feet or 457 meters. Okay. Now, exposure B actually can be used, okay, for, ito na yung exposure categories. Kasi kanina yung kanina na discuss is the roughness category or the surface roughness categories. Now, the surface the exposure will depend on the surface roughness. Okay, so if your surface roughness is under the category B, you should use exposure B. Okay, wherein exposure C naman applies for all cases where exposure B and D does not apply. Okay? So, it means that, to simplify, exposure C applies only to surface roughness categories under C. Okay? So, surface roughness B, that will just be paired with exposure B, and then yung exposure C naman that will just be paired with exposure C. Okay? So, yun. Okay, yung mga exposures natin. Okay? So, next one will be exposure D. Ano ba yung exposure D in here? Sabi dito, exposure D shall apply where the ground surface roughness as defined by surface roughness D naman. Okay. So, we have exposure. Kumbaga, it is paired, the surface roughness is paired with their corresponding exposure. So, if B is to B, C is to C, and then D is to D. So, yan lang naman yung idea behind the exposures. So, whatever is your surface roughness, that will be the exposure. Okay, surface roughness B, that's exposure B. Surface roughness C will just be under exposure C, and then roughness D will just be under exposure B. Okay? So, yun yung ating exposure requirements. Wherein, meron tayong exemption naman. Okay? So, an intermediate exposure between the preceding categories is permitted in a transition zone, provided that it is determined by rational analysis method defined in a recognized literature. So, that's the only exception. So, what if both of the categories under exposures, okay, is borderline? Baga, in between exposures and roughness lang sila. Which really happens, okay, in practice, which really happens, okay. So, ang ginagawa is that there will be, kumbaga, further studies based on the literature, published literature, and that's not under the control of the engineer anymore, but rather it will be under the guidance of the agency concerned with the climatic data. Okay? So yun yung exemption natin doon. So ang final say will be the agency concerned. Okay? So next we have the exposure requirements. Okay, meron tayo exposure requirements in here. Good. Alam mo, iniisip ko yung substee na yan. Okay, medyo na-distract ako dun sa substee. So we have exposure requirements as well. Okay. So directional, we have the 4 procedures again. What are the 4 procedures again earlier that for the MWFRS system na nasabi? Do you still remember? Okay, let's call someone. Let's try to call someone. Si Jarvie. Jarvie, do you still remember what the 4 procedures involved in the analysis of the wind load for MWFRS system?
Sir, yan ba yung ano, sa may, anong tawag na kasi, wind wall, ganun ata yung side.
There are actually 4 procedures, diba, under MWFRS system. Dun sa general, sa procedures kanina, sa MWFRS. Ito na yung dalawa, ganon, Jarvie, ito na yung dalawa sa screen natin. First, we have the directional procedure and then the envelope procedure, other 2.
Ordinance. Tapos with ordinance.
Ayun, okay. So, yun guys, we have the directional procedure for building appurtenances and the other one is the wind tunnel. Okay, very good, Jarvie. And then there's, siya din ba yung sumagot kanina? Like, there was someone who, sir, yun ba yung ganon? Ganon siya. Sino yun kanina? Parang iba kasi yung boses. Si Jarvie. Is that Jarvie? Or hindi? Or hindi?
Sir, nag-e-echo kasi, wait lang, sir.
Okay, si Jarvie kanina. Okay.
Sorry, sir.
Okay. Okay. Thank you, Jarvie. Very good. Okay. So, exposure, meron tayong kanya-kanyang exposure requirements, guys, which is making our life complicated. No, we have a different exposure for the different procedure. Now, for the directional procedure, meron dito, sabi dito, for each wind direction considered, wind loads for the design of the MWFRS of enclosed and partially enclosed buildings using directional procedure of Chapter 27 shall be based on the exposures as defined in section 26.7.3. Okay, so whatever is the exposure that 7.4 na tayo. So whatever is the exposure categories that was defined by the previous section of the code kanina, yung exposure B, ganyan, yung exposure B, sa roughness B, mga ganon. Yun yung ipa-follow ng directional procedure for the MWFRS. Wherein yung sa envelope procedure naman, shall be based on the exposure category resulting in the highest wind loads for any wind direction at the site. So for envelope procedure, we need to test or we need to check kung ano yung possible combination that will give us the most critical loading. Okay, the most critical loading. So it could be exposure B, it could be exposure C or D. It really depends kung sino yung magbibigay sa atin ng highest critical wind loading. Now in the next slide in here, it says there naman for directional procedure building appurtenances, yung kwan dito, yung ating exposure, okay, will depend on the appropriate exposure for each wind directions considered. Okay, so yung first 2 kanina, regardless of the direction, you have to choose kung ano yung magandang exposure. So sa kanina, sa first procedure, directional, yung sections ng 26.7.3 yung gagamitin. Now, sa envelope procedure, whichever gives the highest value, okay, whichever gives the highest value, in general, okay, in general, whichever direction it is, yun yung gagamitin. Now, in directional procedure, you have to consider the direction of the wind. Okay, you have to consider the direction of the wind. So it depends in each particular phase of the, kunyari four-sided yung building mo. It depends kung ano yung value or mag-base ka sa 26.7.3 pero yung application ng loading will be in each phase. Okay, in each phase. So yung mga exposures kanina, isa lang siya. Okay, yung first two will be in general mo. Pero ito, whichever more appropriate in that particular phase depending on the wind direction. Okay? Yun yung gagamitin mo. Okay? So, sa components and cladding naman, that will just be similar to the second procedure. Pero ito, CNC na siya. Okay? So, similar lang siya sa envelope procedure. Pero nga lang, yung second procedure kanina, that's for the MWFRS lang. Pero ito, components and cladding naman, whichever will be the exposure type and the roughness type that will give you the most critical loading yun yung gagamitin. Okay? Next, we have topographic effects. Wait lang, pwede bang uminom muna? Inom muna ako, nag-dry yung lalamunan ko. So, wait lang guys. Ayan. And can I take a moment to go to the bathroom? In a bathroom break lang ako saglit. Okay, going back to the discussion, let's proceed with topographic effects. So, so far, we're under the general tawag dito, general requirements lang naman. So, wala pang masyadong complication in here. Okay. So, let's proceed to the topographic effects. So, the wind speed up over hills, ridges, and escarpments. Okay, you just Google na lang what ridges and escarpments mean. Okay, pero these are actually topographical features of an area. Okay, so when we say topographic, what do we mean when we say topographic? Anyone can chat na lang dun sa ating ano dito, in call messages sa Google Meet kung ano ang ibig sabihin ng topographic. Okay, what do we mean when we say topographic? Okay? Chat nyo na lang guys yung response niyo when what do we mean when we say topographic, then balikan ko. Okay, so meron tayong wind speed up over hills, ridges, and escarpments, mga ganyan. Okay, so meron tayong tinatawag na wind speed up. Ano ba itong wind speed up na to? Okay, imagine guys, if you are for example in a flat surface. Okay, in a flat surface, diba, in a flat surface, if you try to blow that, okay, like that, parang wala namang masyadong change. Okay, walang masyadong change in the velocity of the wind. But if you try to blow into something like a flat, a slanting surface, Okay. There's this force of the wind that is actually amplified at the top. Okay? So kasi babalandra yung wind ng ganyan. Okay? So there's a sudden change, and that change is actually causing the wind to gain more pressure. Okay? Kasi it has an impact, okay, on the surface of that particular feature. Okay, so when we see top view of a land or the surface, so the topographic nature or the topographic is actually just a feature of the surface. Okay, how rough is the surface, how slopey is the surface, those are that's topographic topography names. Okay, so dun guys sa ating structure, we need to consider as well if it is located somewhere in a hill or maybe in a flat surface lang. Okay. So, meron tayong certain conditions, okay, in that should be included in the wind speed, on the modifications on the wind speed. So, ano itong mga conditions na to? Ayan. So, we have here 1, 2, 3, 4, 5 conditions. Okay. So the first one, the hail ridge or escarpment is isolated and unobstructed upwind by other similar topographic features of comparable height for 100 times the height of topographic feature. Okay, so yung upwind na yan, guys, do you still remember the tailwind and the upwind? The upwind is somewhere, if you have a plane, what is the upwind? It's here. Sa mukha ng plane, and the tailwind is somewhere at the end of the plane. That's upwind and tailwind. Okay, so yun yung mga yun. So pagka dito, that's the leeward side, and then wayward side yung sa dulo. Okay, so kung saan man yung malakas yung impact or the wind is kumbaga parang magkakaroon ng collision between the wind and that particular object. Okay, doon talaga yung malakas yung impact. Okay, so doon yung malakas yung impact. Okay, wherein yung at the last part of the plane itself, hindi masyadong malakas yung impact doon kasi it was already absorbed, or the most impact is at the face or at the head of the plane itself. Wherein yung dito na hindi na siya ganun kalakas na impact. Okay, so that's the principle behind yung wind speed up na yan. Okay, so in here, it will be, sige, going back. So the first one in here, dapat yung inyong hill, ridge, or escarpment is isolated. Okay, and unobstructed. Okay, upwind by other similar topographic features of comparable height for 100 times the height of the topographic feature itself. So that's 100 times age, or 3.22 kilometers, whichever is less. The distance shall be measured horizontally from the point at which the height of the hill, ridge, or escarpment is determined. So let me try to give you illustration, okay, para mas maintindihan ninyo. But I'm not sure if I will be drawing it very nicely. For example, lang. Okay. Saan na ba yung natin? Google Meet. Ayan. I am now sharing my screen. Okay. So, ito yun. Wait. Basahin ko nga ulit yung provision. So, yung provision. Okay, the renewable escarpment is isolated and uncertain when other were comparable to height 100 times the topographic feature, whichever is this. Totally from the point which the region is determined. Okay. So, ito yung age natin. Oh, by the way, meron palang figure dito. Okay, let me let me stop broadcasting. Meron palang figure dyan, sorry. Ayan. Meron tayong figure doon, Prince. Pwedeng pa-share nila ako ulit. Okay. It's in the next slide pala. Ano ba yan? Nabuang na. Okay. Prince, pa-share na lang ako nung screen mo. Ayan. Thank you. Instructor sa foundation, engineering, ano ba yan? Ano na ngayon? 3 lang tayo kasi hindi tayo nag-discuss ng first week, di ba? Okay. So, wala pa pala kayong instructor. Oh my God. Okay. Paano yan? Okay, midterm na lang kayo mag-start na mag-discuss. Okay. Diyos ko. Okay. Tagal kasi mag-approve ng HR, tsaka nila gano'n, VP admin. Okay. So, meron tayo dito, escarpment na tinatawag. So, as you can see, that is your escarpment in there, the left side. And then yung ridge naman natin is this one. So, yung escarpment natin, yun lang is, kumbaga, tawag dito, elevated siya and then continuous na yung kanyang level. Okay? Pero yung escarpment naman, yung inyong ridge naman, or yung inyong hill, those are just similar. Siya, parang nagbukol siya ng ganon, and then there is a change in slope and then it goes back to the original level. Okay? So yung escarpment nyo, wala nang going back to the original level, pero yung inyong ridge or asymmetrical hill, it actually has a return of the initial leveling. Okay? So that is your ridge or escarpment. Now, the hill or the ridge or escarpment protrudes above the height of upwind terrain features within 3.22 kilometers. Radius in any quadrant by a factor or 2 or more. So those are now the conditions in which you are going to consider the upwind, the topographic effects rather, for the wind speed up. Okay? So, yung pressure diagram natin dyan, yung speed up na ganyan, bakit ganyan yan? Yung sinasabi natin. Kasi guys, when you tend to blow, okay, the pressure of the wind is actually directed upward. Okay, pag ganun siya. Okay, so if I'm going to blow here, tatama yung wind mo dito and then gaganon siya. So that is why yung pressure diagram mo dun sa inyong escarpment and yung hill ninyo is at the surface level, malaki siya and then pataas ng ganon. Okay, kasi nag-dissipate na yung wind sa taas. Okay, mas malakas yung pressure dun sa baba. Okay. So ito yung mga called topographic multipliers natin for exposure C. For exposure C lang naman to, okay? For exposure C lang. Okay? So kunin lang natin yung ratio between the LH and your ang tawag dito, your height. Okay? Yung height dyan na tinatawag, pinapertain natin is actually the height of the escarpment and the hill itself. Now, what is LH? As you can see, yung LH natin dyan, that is located from the middle, okay? The middle of the height to the point on the escarpment or the hill being covered. Okay? So that's the LH. Okay? Now, ito yung multiplier natin, K1, K2, mga ganyan. Okay? So, check nyo lang later on. That is a tabular in nature naman. Okay? Now, on the next slide, meron tayong values dyan. Okay? Or meron tayong, ang tawag dito? Ang tawag dyan? Additional reminders or maybe may additional reminders tayo. Okay? So, meron tayo dito for values of age over LH, mga ganyan. kung wala doon sa table, you can do a linear interpolation. Do you guys know how to do a linear interpolation? Do you guys know how to do a linear interpolation? No? Okay. If you are given two values and you're like looking for a value in between, okay? In between those two values, pwede tayong maggumawa ng algebraic expression. That's just upper value minus lower value all over the given variable at that particular value minus, sabihin na natin variable up and then variable down should be equal to the unknown value minus the lower value all over the variable of the unknown value minus the tawag dito, the variable of the lower value. So that's a linear interpolation. Kumbaga kunin mo lang yung mag-ratio and proportion ka lang guys, ganun. So magma-minus-minus ka lang, okay? And then kunin mo lang yung ratio nila. That should be kasi the nature parang slope siya guys, okay? Slope using 2 points, okay? Slope between 2 points. So kapag linear kasi ang nature ng equation, whatever will be the point between those 2 points lying in the line connecting the 2 points, yun din yung slope ng point na yun. Okay? So whatever the slope of the general equation, that's also the slope of values in between those 2 points. Okay? So I hope you know how to interpolate. Okay, so next slide tayo. We have parameters for speed up over hills and escarpments naman sa next slide. Okay, so those are the topographic factors, guys, K, Z, T. Okay, so those are topographic factors. Okay, next, meron tayong computation, guys, for the topographic factor actually. Okay, we have computation for this. Now, after natin malaman yung values ng K1, K2, and K3, yung topographic factor natin, KZT, yun na yung magiging final value natin. Okay? So, what's the formula? Under there, sa equation, that's 1 plus K1, K2, K3. Square mo yung sum nila. That'll be your topographic factor. Okay? So, that's your topographic factor. Next slide po tayo. So, sige pa. Next pa. So, in here you have 26.8.2 and then, okay, that's just the topographic factor. Pero if site conditions and locations of building and other structures do not meet all the conditions specified in 26.8.1, then KZT is taken as equal to 1. Okay, so that's your KZT if the conditions in section 26.8.1 is not satisfied. Okay, so titingin tayo doon sa 26.8.1. There are actually 5 conditions there. Pero pag hindi niya na-meet, you can just use KZT as 1. Okay, next, ground elevation factor naman tayo. Okay, 26.9. Ito used for adjustments lang of air density. So yung KE natin is permitted to be taken as 1. Pero if specified by the code, gagamit tayo ng table 26.9-1. Okay, so gagamit tayo ng table to identify your KE. I think I put the KE table in here. Okay, so next slide will be the velocity pressure coefficient. Okay, exposure coefficient. So ito yung ganun guys, yung KZ or KH natin. Okay, so lahat ng applicable values will depend on table 26.10-1. Okay, for sites naman located in a transition zone or borderline ng dalawang exposure categories, okay? Intermediate values for KZ or KH between those shown in 26.10-1 are permitted, provided that they are determined by rational analysis. Okay, method defined in the recognized literature. Okay, so normally, if wala naman yung exposure category, if borderline siya between exposures, okay, lies in between two exposures, rational analysis na po yun. It's actually not us who's going to determine the value of the KZ or the KH, okay? But it will be the experts on the field na, okay? So, hindi na tayo problemahin. Pero I think there are some exceptions again in the values of the KZ and KH later on, okay? So, next slide tayo, we have ground elevation factor, KE. Ito na yun, guys. Yung KE ninyo, pili kayo dyan. Okay, depende kung ano yung elevation ng inyong site, okay, above sea level. Okay, so in here we have less than 0, 0,000, 2,000, mga ganyan, in terms of feet, pero in meters, ayan siya. Okay, and then yung corresponding ground elevation niya. Okay, so what if in between siya ng 1,000 and 2,000? Can you try? Do you have your calculators with you? Do you have your calculators with you, guys? None? Okay. Let's try to interpolate this one. Okay. What if the value of your the ground elevation level is between 305 and 610? What if 625 siya? Okay. Or rather, it's 450. What if 450? If you're going to apply, if you're going to do interpolation, okay, what will be your value? Can you someone try and let's see if pareho yung value niya sa akin? 450 yung hinahanap natin. Okay, what are your values? Mine is matagal mag-solve kasi shift solve yung ginamit ko. Matagal siya mag-solve, guys. So, by interpolation to, linear interpolation. Okay, so the value of my KE is 0.946. I hope you get, ayan. Okay, 0.946. Thank you, ayan. So, alam naman ninyo mag-interpolation pala. Okay. So, yun yung value ng ating KE kapag ganyan. Okay? So, later on, that will be part of your quiz. So, you need to get the value of your KE based on this table. Pero open naman yung ating mga gano'n. So, meron tayong dito, guys. Conservative approximation kasi yung 1. Okay? So, yun na yung, pwede namang hindi na mag-check ng values ng KE natin. Especially if tinatamad na kayo mag-solve. Ngayon, pwede natin i-assume na lang na 1 na yung KE. Okay? Pero kung gusto niyo talaga ng more accurate, kasi if you tend to use the conservative value, that will compromise economy of material. Okay? So, if you're going to use KE as equal to 1, okay, medyo mahal yung cost mo, especially if yung inyong elevation naman is somewhat below the belt. Okay, somewhat mababa lang. Okay. So meron din tayong anong tawag dito? KE shall be determined from the above table using using interpolation or from the following formula for all elevations. So, meron din pala tayong formula in here. Okay, pero yung unang formula dyan is in terms of feet. So, gawin nyo na lang is yung second formula yung gagamitin. Okay, so that is either by interpolation or by this formula. Pero i-specify naman later on kung ano yung ano dapat yung gagamitin ninyo. Okay? So, next is the table, velocity, pressure, exposure coefficient. So, ito yung kanina, yung KH and KZ. Pili lang tayo dito kung ano yung height ng building natin above ground level. Okay? So those are our KZ and KH. So those are the exposure coefficients. Okay? Next. And here, meron din tayong annotations doon sa bottom ng table. Use 0.70 in chapter 28 exposure B when Z is less than 30 feet. So yung Z ninyo is the height, okay, the height of the building. Okay, pag mababa naman siya ng below 30 feet, okay, you can use your 0.70 in chapter 28. Okay, I think chapter 28 is actually envelope. Okay, envelope procedure yon. Okay. Envelope procedure ba? Okay. I think it's envelope procedure. Tayo kasi we're directional kasi yun. Nasa directional procedure tayo. Okay, first procedure tayo ng MWFRS. So yung envelope procedure will be discussed, okay, in chapter 28 of the code. Okay. So yung pressure coefficient natin na Kz naman may be determined from the following formula. Okay. So if your Z is less than 15 feet, 4.6, your Kz is actually equal to 2.01 times 15 all over Zg raised to 2 all over the alpha. Okay, nasa yung alpha dito, values ng alpha. Okay, meron tayong formula for the alpha, the determination of the alpha. Anyway, sige. Ayun. So ito, yung alpha and Zg natin pala is tabulated in 26.11-1. Okay? So you're going to use the formula, or you can use linear interpolation again. Okay? So exposure categories are defined in section 26.7. Okay? So kumbaga ang code talaga natin is more on hanap-hanap ng provisions. Okay? Hanap-hanap ng provisions and how are we going to apply that provision. Next thing is the velocity pressure. Next slide po tayo. Okay. We are about to finish, guys. Don't worry. Okay, we're about to finish. Konting slides na lang naman na to. I think there are 66 slides, and I don't know if anong slide na tayo. Okay. So here are your formula for your velocity pressure. Kasi we need the QZ. Okay, we need the QZ. So the QZ is the velocity pressure and is defined by this particular formula. The 0.613 kz, kzt, kd, ke. Ang dami, no? Ang daming ganun. Ganyan talaga, guys, sa code. Ewan ko ba kung bakit pa. Kasi in the code, kasi hindi naman nila sinasabi kung paano nila na-derive yung mga formula na ganyan. So, as explained earlier dun sa ating week 1 na discussion, hindi talaga nila sinasabi kung ano yung ang tawag dito, ano yung natin, yung how they come up with that particular variable, no? So tinatanggap na lang talaga natin in general because it was stipulated naman doon sa code na hindi nila pinapakita kung how they were able to come up with that. Pero the only thing that they actually mention is that it's determined through observation or the empirical method. Okay, so more on test sila. Now ito yun. So, yung second formula yung gagamitin mo dyan, yung 26.10-1, because it's in SI units. Okay, meters per second. So, kung gusto niya mag-miles per hour kayo, pero that will invalidate your answer later on. Kasi if your units are SI, you use the SI formula. Okay? Kasi ito yung mga variables natin, KZ, KZT, KD, KE. So, ang daming branching yan, guys. When you're going to compute for KE, mga ganyan, is either linear interpolation or meron tayong particular na formula dyan. Kailangan natin yung ZG. Mga ganon. So, para ang dami-dami nating iba-branch out. Okay? Before natin makuha yung value ng ating QZ. Okay? So, nandyan na yung mga, ang tawag dito, nandyan na yung mga legends natin kung anong gagamitin na formula. Okay? Or yung variable. Next, we have velocity pressure. Okay, so the velocity pressure at mean roof height is computed as QH equals QZ evaluated from equation 26.10-1. So that's the previous equation or the equation we just mentioned. Okay, in the previous slide. So your QH is equal to your QZ. Okay. So the basic wind speed V used in determination of design of wind loads on rooftop structures, rooftop equipment, and other building appurtenances shall consider the risk category equal to the greater of the following. Okay. So a risk category for building on which equipment or appurtenance is located, and risk category for any facility to which the equipment or appurtenance provides unnecessary service. So kanina meron tayong risk categories 1, 2, 3, 4. Okay, whichever applies or whichever category applies to tawag dito to this section, yung velocity na yan. Okay. For the velocity pressure, okay, magmo-modify tayo ng risk categorization. Pero anyway, there are kino-consider naman natin normally na risk categorization is under 1. Okay? Para kasi parang maximize natin yung risk in order for us to get the best design. Not really the best design, but the more stable design. Okay. Next, we have 26.11. We have 26.11, guys, the gust effects. So in general, we can consider the effect factor as 0.85. That's the general acceptable na value, 0.85. Now, frequency determination tayo. May conditions din na we have to do. Kumbaga, i-modify natin yung gust effect factor na yan. Okay? So, ang mangyayari is that meron tayong formula later on. Okay? May mga formula na yan. Okay? So, in general, we can use 0.85 as the gust effect factor. Then we have a frequency determination to determine whether a building is rigid or stuck or flexible. We use section 26.2. So, okay. Required kasi sa atin i-determine if yung building natin is rigid or flexible. Pag sinabi natin rigid, kahit bugaan man ang bugaan ng wind yan, walang deformation na nagaganap. Okay, walang deformation na nagaganap. Now, for flexible naman, bugaan mo ng wind na sobrang lakas, nagsusway lang siya. Nagsusway lang. It causes the structure to vibrate very, not really, hindi siya ganun kalakas na vibration, but medyo minimal lang yung vibration. So, yung fundamental frequency natin, yun yung gagamitin natin, okay, for determining the gust effect factor as well as the rigidity of the building. Ngayon, yung N1 natin shall be established using the structural properties and deformational characteristics of the resisting elements in a properly substantiated analysis. So yung low-rise buildings as defined in section 26.2 are permitted to be considered rigid. Okay? So kapag low-rise buildings, consider na natin siyang na rigid. Okay? Pero yung mga matataas na, it's up to you guys if we need to determine, it's up to you if a best practice ninyo, okay, if it is rigid or flexible. In my case, kasi I tend to use the flexible, okay? I would really recommend the flexible kasi that gives you a more accurate result. Pero yun nga lang, sobrang matrabaho kasi sobrang daming gagamitin na variable and formula. Ngayon, next slide tayo. That's the limitations for the approximate natural frequency. So, yung alternative natin for performing the analysis of the natural frequency of the building, pwede tayong mag-approximate. Pero, okay, meron tayong requirement for the approximation. Okay, so, first one is the building height, okay? And the second one is as well a building height. Pero yung first one, building height is less than 91 meters. And yung second one is less than 4 times its effective length. Ano ba ito effective length na to? Now, the effective length is further discussed in the next slide. So how do you determine the effective length? Gamit lang tayo ng formula na ito. That's the ratio between the summation of your HI and LI from 1 to N all over the summation of your HI from 1 to N. So ano ba yung HI? That's the height above the grade of the level. And then yung LI naman, that's the building length at the level I parallel to the wind direction. Okay, so at level I ito, so it could be that single story ka lang, so that's only one level. So 2-story, that's 2 levels, 3-story, etc., and so on and so forth. That will be your building level. Okay, whatever is the length, okay, of the structure parallel to the direction of the wind. Okay, yun yung gagamitin natin na Li. Okay, so yung L effective mo, that is how you get the computation, or that's how you're going to compute for the effective length. Okay. Next is, next slide po, approximate natural frequency. Okay. Meron tayong approximation of natural frequency. So this is how we're going to compute the natural frequency of the building. Okay. So in the next slide, we have there the formula. Okay. So first, we have to determine if the building is actually ang tawag dito, structural steel or reinforced concrete, or the combination of the two. So next slide tayo, Prince. So makikita niyo sa next slide, yun yung formula na gagamitin. Okay, so for structural steel, yung first formula is actually NA equals 22.2 all over H raised to 0.8, mga ganyan. So it depends kung ano yung moment resisting framework, kung structural steel ba siya or concrete. Meron din yung combination ng dalawa, structural steel and concrete naman. Okay? Combination ng dalawa. So, meron din tayong concrete or masonry. Okay, ano ba yung masonry na tinatawag, guys? What is masonry? What is masonry? Anyone, what is masonry? What's the difference between concrete and masonry? What's the diff between concrete and masonry? Wala kang idea. Okay, who can give na lang an example of masonry, and who can give an example of masonry?
Brick, sir.
Ayun, brick and mortar. Anything that is made from brick and a mortar, that is a masonry. Okay, that's masonry. Okay. Alam mo ba sa architecture, ang tinuturo nila, masonry daw is anything made out of concrete. Sabi ko, okay. That is not masonry. Oh my God. Nag-architecture ka pa. Ayun. Although dapat mas alam ng architect to, guys. Pero nagulat lang ako nung sinabi nila, what is masonry? Tapos sinabi ng isa, an architect, it's anything that is made out of concrete. Sabi ko, okay. Hindi ko na pinuna siya, pero kakahiya naman. Punahin ko pa siya. Okay. Bahala na lang siya mag-discover. Okay. Mag-discover on his own. Ayan. Kasi iba din kasi yung feeling, guys, ng pinupuna ka, no? Pinupuna ka. Pero in your case, you can make puna-puna of me. That's okay. Okay. Pero in your profession kasi later, pag nag-work ka, pag pinuna ka nila because of your mistake, parang nakakakwan din yun. Especially when there are people or there are in public siya, gano'n. Hindi lang kayong dalawa. Gano'n. So medyo nakakasagad ng loob yun. In my case, I just don't know with you guys. Ganun. Lalo na pag maraming tao talaga, tapos pinuna ka nila. Paglalaban mo talaga yung sagot mo kahit mali ka. Ayan, that's the common nature ng tao. That's the nature of mankind. Okay. So next tayo, okay. So, ayun guys, yung pag-determine ng natural frequency, it's just using those formula. Okay. So, yung mga yan. Okay. And then meron tayong CW, my God, mga ganyan. Okay, so mayroon tayong CW. That's for concrete and masonry. So medyo complicated yung formula nila. Okay. So 26.11.4 naman tayo, rigid buildings or other structures. Okay. So ito for rigid, mamaya meron for flexible din. Okay, may flexible. So how do we determine the gas factor for gas effect factor for rigid buildings? Okay, although it is taken as 0.85 normally, okay, pwede din natin siyang computing using this formula. Okay, so your G, that's now equal to 0.925 multiplied by 1 plus 0.7 G cube IZ sobrang dami, sobrang haba. Ano yan? Ano ba yung mga yan? Okay, ano yung mga yan? So, ano ba, what do you mean when you say gust ba? Gust. What do you mean when you say gust? Sige, you can chat na lang, guys. Ito ba yung ganon? Yung pagbugso? Ganon, di ba? Pagbugso, ganyan. Yung sa TV. Am I saying the right term in Tagalog? Pagbugso, ang ganon. May lakas na ganon at pagbugso, ganon, di ba? Pag nagre-report sila ng mga balita about mga ganon, mga hurricanes, mga ganyan. So I think that's a gust. Okay, pagbugso. Parang yung pulse ng wind. Suddenly may pulse ng wind. Okay, may pulse siya ng wind. Something like that. Okay, I think that's the gust. Okay. Okay. So ano yung IZ? Ano yung mga yan? Okay. So next slide tayo. What is IZ? So yung IZ ninyo, that's the intensity of the turbulence at height Z. Okay, where Z is the equivalent height of the building or structure defined as 0.6 H. Okay, but not less than Z minimum. For all building or structures heights, H, Z min and C are listed for each exposure in table 26.11-1. Then yung GQ and GV ninyo shall be taken as 3.4. Okay, the background response Q is given by ito. So meron na agad tayong value ng GQ and GV. Okay, meron na tayong value. That is for rigid structures lang, guys, ha. So that's 3.4, wherein yung C, Z min and C values will be taken from table 26.11-1. And then you're going to use this formula, the Q, okay? So that's the square root of 1 all over 1 plus 0.63 and so on and so forth, okay? So yan yung problema sa code minsan na mahirap intindihin, okay? Kasi bibigyan ka ng formula, pero yung mga variables doon sa formula, within that formula, may sarili din silang formula. And then, parang kung branching yung formula natin, guys. That's the main flaw na nakikita ko sa code natin. Sobrang dami ng formula na branching siya. Hindi mo makukuha yung value na to pag hindi mo kinompute yung formula na ito. Tapos yung formula na yon, yung mga values doon, yung mga variables doon, may sarili yung formula. Okay? So, yun lang yung mahirap intindihin sa code natin. Okay. How about if you have a flexible structure? How about if you have a flexible structure? Okay. Next slide. So kanina rigid yung inyong structure. So you're going to determine the gust effect. Okay. So what if we have a flexible structure? Okay. So your G now will be different from the value of your G in the rigid or in comparison to the rigid one. So if the problem is stated that it is a flexible or dynamically sensitive building, okay, yung GF na formula nyo is this one, okay. Similar to the rigid, yung GQ and GV ninyo shall be taken as 3.4, okay. Pero may iladagdag tayo na bago, GR. Ano naman itong GR na to, okay? Yung GR ninyo is given by this formula, okay. So 2 ln of 3,601 plus 0.577 all over the square root of 2 ln of 3,601. Okay, wherein yung R ninyo is the resonant response factor. Okay, and then meron na naman yung sariling formula, guys. Okay, so yung inyong ang tawag dito, resonant response factor, meron yung sariling formula. Okay, so the next slide will give you the formula for the resonant response factor. Next po. Yeah, we're about to finish. I'm trying as much as I can to finish this before the time. Okay, hopefully matapos na natin siya. Anyway, ito lang naman yung point. So again, guys, yung resonant response factor ninyo. So 1 of eta, mga ganyan. Oh my goodness. Okay, so damping ratio, kasi guys, we actually put in the structures, meron tayong mga damping equipments doon. Ano ba itong mga damping equipments ito? These are like equipments na ikakabit mo sa frame ng building, wherein kapag nag-sway yung building, parang hihilain niya pabalik. Ganun. Parang binabalance out niya yung building para hindi siya mag-swing ng sobra. Those are damping equipments. So ito yung magiging formula mo for resonant response factor. Okay? Tapos andyan yung mga legends niya. Yung N1 mo, that's the fundamental natural frequency. And then yung RL mo, that's just equal, R sub L mo, that's just equal to R, ang tawag dito, if that is equal to RH, yung setting ng, hindi ko alam kung ang tawag dun sa ganun, na symbol. Pero normally, that's the symbol for viscosity, guys, ng tubig. Okay? So that is equal to 4.6 N1 times H over VZ. Ngayon, may computation tayo for the VZ again. Okay, how to compute for the VZ? The mean hourly wind speed, that's now B beta or B bar times Z bar all over 10 raised to alpha. Okay, bar multiplied by V. Tandaan ulit na ang B and yung ating alpha bars are constants listed in 26.9-1. So later on in your quiz, though I did not show any examples, magko-compute pa rin tayo. Pero yung mga values dyan will be given and then will be, the tables will be given. Okay, the tables will be given. Yun lang yung mahirap dito, guys. Maghahanap lang tayo ng values. Maghanap tayo ng values, guys, for the formula, the variables in the formula. So, yun yung mahirap kasi maghanap ka pa ng value. Okay, so, igaganon-ganon mo siya. Scroll ka. Okay? And then we have, next slide, rational analysis. Okay, so we have the rational analysis. It will be used to determine other gas effect factors other than stipulated in sections 26.11.4 and 26.11.5. Pero hindi naman mag-rational analysis kasi hindi naman natin ginagawa talaga yan. Kung ano na lang yung available dito na formula and ang tawag doon, available formula and methods, yun na lang ang gagamitin natin. Okay? So, meron tayong limitations as well. Okay? So, meron tayong tinatawag na combined gas effect factors and pressure coefficients. Yung pressure coefficients natin, that's GCP, GCPI, and GCPF. Okay? So, meron tayong values nito na naka-table siya. Naka-table siya later on. Okay? So, may table dito. I think may table dito na in-include yung GCPI and GCPF. So, naka-table naman yung mga values na yon. Okay. So, next is enclosure classification. Okay. So, how enclosed is the building? Okay. How many, or what's the ratio between the area of the opening with respect to the gross surface area of the building? Okay. So those are what we pertain to as enclosure classification. Okay. So kailangan natin yung i-consider in determining the wind loads. Okay. Now let's proceed to the next slide. Protection of glazed openings. Okay. Ano ba itong mga glazed openings na ito? These glazed openings actually pertain to your windows, something like that. Okay? Windows na masyadong exposed. Okay? Masyadong exposed siya. So there's a need for you to protect your glazed openings. Anyway, the glazed openings will be further discussed. Okay? Kasi yung provisions kasi ng glazed openings in here, that's just the general. Pero para mas maintindihan nyo siya, you have to actually read the ASTM book. Okay? Pero in our case, hindi na tayo magko-consider ng ASTM. Okay? So kahit i-skip na natin yung glazed openings, guys. Okay? Okay. So kahit i-skip na natin yan, punta na lang tayo sa table 26.13-1. Ayan guys, yung mga protection requirements natin. Okay, so kahit wala tayong magganyan kasi wala naman tayong, wala natin i-consider yung glazed openings later on sa design. Okay, kasi magko-consult pa tayo ng ASTM. I don't think so. Ang hirap na intindihin ng code eh. Okay? So, ito yung mga values natin for GCPI, guys. Okay? So, what will be the enclosure classification? We have to determine the enclosure classification. So, in here, in the table, mayroon tayong criteria for the enclosure classification. First one is enclosed buildings. If the area of the opening is less than the smaller of 0.01 area gross, and then, or 4 feet, okay, or 0.37, and AOI all over AGI less than or equal to 0.2. So you have to check first, okay? You have to check first the criteria, okay? Kung saan magpo-fall yung classification ng enclosure ninyo. So we have enclosed buildings, partially enclosed buildings, partially open buildings, and then we have open buildings. So how are you going to check the enclosure classification? You just stick to the criteria of each respective enclosure. So yung AO dyan, that's the area of the opening of the building that includes all the doors and the windows, mga ganyan. And then yung AG naman, that's the gross area of the building itself, the face of the building. Okay, so yung gross area na yun na tinatawag natin, including yung area ng butas. Okay, the area ng butas. So the area of the face or the side of that building, that is the AG. Okay, so identify nyo lang kung anong classification. And then yung GCPI, internal pressure coefficient niya is stipulated dun sa end ng table. Yung positive 0.18, negative 0.18, mga ganyan. Okay? So, plus minus signs signify pressures acting toward and away from the internal surfaces, respectively. That's why we have positive and negative values there. Okay? So, next tayo, exceptions. Okay? So, other testing methods and performance criteria are permitted to be used when approved. Okay? So, we have glazing and impact protective systems in the building and other structures classified as risk category 4 in accordance with section 1.5 shall comply with the enhanced protection requirements of table 3 of ASTM 1996. Okay, so wag na tayong mag-ASTM. Okay, wag na tayong mag-ASTM. So what if we have multiple classifications of buildings? What if we have multiple classifications? Well, if the building definition complies with both open and partially enclosed definitions, it shall be classified as an open building. Okay, so that's the tawag ito. Pag nag-fall siya in between open and partially enclosed, you're just going to put there open okay. So ika-classify nyo na siya as open. Okay. If it fell between open and partially enclosed. You just use open building na lang. Okay? So next is yung internal pressure coefficients natin. Okay, internal pressure coefficient or the GCPI shall be determined from table 26.13-1 based on the building enclosure classification determined in or from sections 26.12. Okay, and then we can also use reduction factors, guys. Okay, we are also using reduction factors in terms of the GCPI. Okay, so the next section will tell you or will show you the formula to use in the reduction of the internal pressure coefficient. Okay, so the GCPI shall be multiplied by either 1 or this particular formula. Okay? Ayan. So, pwede kayong mag-reduce. Okay? This is to make the design more economical. Okay? More economical. Okay. So, yan yung magiging formula ninyo. And the last slide will be tornado limitation. Okay? So, in the wind loads, ang tornado pa, it's not considered as the wind load. Okay? But rather, it's considered as a live load. And it is basically under the impact loadings. Okay? So, yun lang yung sa provisions ng tornadoes. Okay? So, that ends our week 3 discussion Okay, so we have almost 1 hour pa na time. Any questions, clarifications so far with